Lab 1. For the lab of today, you will be using set operators. Then you will have to manage tables, how you can create them, how you can insert rows. Then you will have sequences so that you can add an automatic index, you can add synonyms, as well as you can add indices based on which you can search faster, as well as you can create views. So let's see, as a recap, whenever you have an SQL statement, you start with a select, then you have the column name. After adding all the needed column names, you can also add an aggregated function according to a column name, meaning that in this row you just apply your aggregated function for a group of rows. Okay, so you would group, let's say, based on job ID, based on department, and in this way you will have multiple rows based on which you can apply a function like sum, minimum, average, and you take it from a certain table. After that, you do the filtering per row according to an operator and a value. You can group it by column name because you need it for your aggregate function. Okay, so this was the part with per country, per department, or if you want to see them per city, let's say, as well as you can add a condition for the aggregate function, but you don't place it inside where you put it based on having a certain operator. Here you have the SQL joins. So as you remember, you see the two tables A and B as two sets. When you have A left join B based on common key, so you have E of key equal B of key, and it's a left join, it means that you have the whole set A. When you've got the right join according to table B and you have common keys, it means that you need to take table B. Then whether you've got an inner join, it means that you take the intersection between A and B according to their common key. Also, you can have the left join. And here, the left join, you need to have B of key is null, whether you want just the elements which belong just to A. Okay, so in this case, you would add this condition with where B of key, such that you have no common elements here at the intersection. Then the same thing you can do for B. It means that you will have the right join, and based on the right join and the keys which they have in common, you will have A of key to be null. Also, in the case of intersection, it is this inner join based on common keys. Whether you want a full outer join, it means that you have A full outer join with B based on common keys, as well as you can have the reunion without the intersection, meaning that you have a full outer join of table A and B. You will have now this A of key equal B of key, but now you will say that you don't have anything matching, meaning that A of key is null, as well as you need to have B of key to be null. Then you will have the operators, like here you can have the union, you can have the intersection of or minus to have a set minus the other, such that you can get your unique pairs. And in this case, you would like from out of all the country IDs and country names, taken it from the table countries, you want to neglect those that have no departments in them, meaning that you have the minus, and now you need to select also country ID and country name. So you select the also to create pairs with country ID and country name, and you take country ID from locations as well as you take the country name from countries. So it means that you will do the connection between locations L and you need to join it with country C, such that the link is done on the relationship that the country ID of locations need to be the same as the primary key inside countries, which is C.country ID. Then you have also to see that you don't want any departments in them. So you need to check which are these pairs that belong to departments, because you do the minus. So it means that according to departments, you link it based on d.location ID and l.location ID. Oh, let's see then how it looks like. Okay, so it would be just Germany, which exists as a country, but you don't have any department inside. Also, what you can do the union. Okay, and now you have all the departments, no matter whether they do have all the countries, no matter whether they do have a department or not. Or you can have, but you already had all the entries from this side. Or where you can have also the intersection. This intersection. Okay, now you have them. Just that you've got departments in Canada, United Kingdom, and United States of America. Okay. Then what you can do is to also perform the union. So now you see that you want those employees who work in department 50 and 80. Before you were having department ID in and you were adding the set. But what you can do is to have the union, and you would have the union between all employee ID, job ID, department ID, taken then from employees and adding the restriction that department ID is 80, I mean 50, and similarly you also put it to be 80. So let's see, we'll take them all together and you got employee ID, job ID, and department ID. So keep in mind that you need to put them like this, or else it will not even work. Okay, so you have an incorrect number of columns and it should match. Okay. Then what you can do is that you want to get all the employees based on last name, department ID, as well as whether the department name is does not exist, so whether it's null, and you want to do the union with those departments who do not have any employee. So it means that you will have this transformation for your employee based on two char of none. So it means that you will have them in this case with this line. So as you can see here, you have a department ID, but you take it just from employees. Okay, it does not exist, so it will be null. As well as, okay, you will also have the department ID and department name from departments, but you don't have the employees. Okay, so you will have them in this case with a line for the first column because it does not exist there. Okay. Then you can even create a table. So in this case, you would create a table my employee, and you will have the ID as being of type number. You can have a maximum 4 digits, and you say that this one you add it as a constraint as being your primary key. Then you will add your last name, which is a string. So you will have this varchar of type 2 of 25 characters. Okay. So this varchar 2 is the fact that it makes a difference with this null. Okay. As well as you get the first name, it's a string, user ID. You add it again as a string, and the salary to have 9 digits, out of which you have 2 after the comma as a fractionary part. So you would create a table employee, and this is how you can see it. As well as you can do the select star from my employee. And, okay. So you will have no data firstly, such that you will have to insert a value inside it. So like here, you need to already know which are the columns one by one. So you should know that 1 corresponds to the first column, okay? Then this Patel corresponds to the last name. Ralph will be the first name. Then you have the user, okay? As well as you have the salary. So this is how you run it. Okay, one row inserted. And now when you do the select star from my employee, okay, it will simply display what you have added. You can also add rows by specifying exactly which columns you want to set, because maybe some can have null values, so you can skip them. And to do the matching and to know what you do insert is like, that first you've got the ID, then last name and everything you put it with. When you have these strings, you have the single quotes. You have last name, you have first name, you have user ID and salary. And after running it, it's also added. Then what we can do is to update. You can update the record based on an index. So let's see here, we would like, instead of the last name Denks, we want it to be Dexter. So you update according to the table name, and you set the name as being the one which you want. So it is the one with single quotes, as well as you need to specify it for which row you do it. Oh, let's see. Star from my employee. Okay, now you've got Betty as being Dexter. Then you can also update all the salaries. So whether the salary is less than 900, okay, you want to set it to 1000. So you would update according to your table name. You set a column according to a value, and you filter based on a criteria, such that now when we do the select start from my employee, okay, you would see that you have the updated values. Okay, you can also commit all the changes, and now comes the part when you've got the save point, and the save point is done when you do some error, and you will have the delete, let's say, of everything that it's inside employee, as well as you want to see that it's empty, so you have the select star, and you can even roll back to what was before at the save point. Okay, and you would commit everything. Then what you have here is a table called employee, this emp. And as you can see, you have again the varchar 2. Okay. So this varchar, as you can see, it has a distinction between null and empty, while the varchar 2 does not distinguish it between a null and empty string. Okay, so this is the case when you have to check whether a value is null. Okay, as you were doing for the manager in the previous laboratories. Now let's have them in this way. You have a table employee, you have ID, and as you can see, you've put it here at the end as having the department ID. Okay, this number of 7 is being a constraint. Okay, which references depth of ID. Okay, this being the foreign key. All right. So we have an employee ID. We have his or her last name, first name, and they also belong to a certain department. Okay. But keep in mind that we also need this department name. Okay. Or else it won't work. Okay. So table does not exist. So you would create in the same way. Okay. You would have a depth. and you have an ID and you have a department name. Okay, this is how it would be. Then you would have your employee. So as you can see, you need to also have it a primary key. So don't forget that as before, you need to specify it in this way that you have a primary key. Okay, so let's say we have a drop table depth. Okay, and then you would do exactly like here. You will have a create table depth, and now let's see what we add inside such that you have an ID, which is a number, and you can see how many departments you've got. You wouldn't have so many. It's a constraint. Okay, so you can find out which would be the type for it by also looking here. So this department ID of 7 means that this is a capacity 7. And this would be, you would have to add a constraint that in my case we have depth ID and you name it as being with primary key. Okay, this one is a primary key. Okay, and then you have depth name as being a varchar 2 to make okay, so to treat also the null and also the strings in the same way. So that okay, this doesn't matter. Okay, then you would also have what? You have the insert. So you would have to have this insert into in the table department. And now you need to say what it has. Well, it has ID and it has a depth underscore name. And you will have to add the values. And let's say we have 1 and we add the IT department. Yeah, yes, keyword remains since I already created. Select star from depth. Okay, and now we've got the name. So let's see here. Now we can add the employee as referencing department. So you create employee based on ID. Then don't forget that even here you need to say that this ID is in fact your primary key. So ID number, okay, you have a constraint and you have an employee ID PK as being a primary key. Okay, then you've got your last name, your first name, department ID, which references the employee. As you can see here, you have the connection between an employee and a department table. Okay, two tables based on which you add a foreign key for department and it references the department ID. Probably employee. MPL. MPL. Okay. So this is the one used in this case, as well as, okay, we did create a table department. So you're having these ones. Create table, depth for it. And you can even insert into, so let's have this one. And you also insert the first you create a department such that you can reference it. You start from the isolated tables and then you add all the links. Then okay, these ones put in. You can also alter the table and add a new column. So let's see. We have MPL. So you will have to also insert the record. Insert into MPL. Okay, we have ID, we have last name, we have first name, then we have the department ID. Okay, and this will be it. So we have ID, last name, first name, department ID. And now we need to specify which are the values. And we have one, okay, and our department. Okay, such that when you do the select star from MPL, you see exactly which are the columns. And now we want to also add a new column, which is this commission as being a number, and you have two numbers after the comma. So this is our MPL. Good. And now we have the select star from MPL. Okay, and commission does not exist. Okay, good. So it will appear here. Then you can also modify the dimension and to see it. So we will have this MPL here. Okay, MPL exists here. You can see the structure. So last name is of capacity 25. Now we want it to be 50, so it means that you will have to alter the table according to the table name, and you need to modify. And after you have here between the brackets, you need to specify which is exactly the column name. And after specifying the column name, you have the type and its dimension. So you modify the table MPL and last name because it comes of capacity 50. So when going inside object browser, and I will have my MPL. Okay, last name is of capacity 50. And describe is the one showing the structure, but in this Oracle Express it won't run. It simply freezes. Then what you can do is to also drop a column. So let's drop the column, this one with commission. Just commission. Okay, let's see. NPL. And here we have commission. So that it is altered when I go inside the SQL browser, EMPL. Okay, it does not exist anymore. And inside data, I can also see the whole record. Okay, so we can drop a column. We can also set a column to be unused. After setting it to be unused, we can drop it for good, not to exist. Also, you can create a table as being the copy of an existing one with this create tables employees to as, and then it can follow an SQL select command as taking the records, so exactly the columns which you want. Like here you have employee ID, which you rename as ID, first name, last name, salary, and department ID. Everything taken from employees. So when you run it, you have the table created, and when I do now the select star from employees, I will see that I have exactly the rows which exist inside employees. So as you can see, you have created a copy according to the selected lines. What you can do is that maybe you have multiple users and you want to set this table as being just in read-only mode. Okay. Then what you can have is to also have permissions of reading and writing. So you would also alter the table. Also, you can drop a table. So no matter if you have just read-only permissions, you can still drop the table. Okay, and this is a department with ID and name. What we did to create with the ID as being a number of 7. So in fact, this depth, okay, 7, and we have the department name also of 25 characters. What we can have is to create a sequence, and for this sequence, okay, we will just assign values automatically. So let's have this sequence created to exist. You start from 200, you increment by 10, and when adding rows, they are automatically incremented based on the sequence, and the maximum value which you can attain is this 1000. So the sequence is created, and now we would like to insert education inside my department table based on the next value of this sequence, as well as here I want to name it administration. Okay. And when going back to this one to visualize it, we have department data, and we see that we have them started from 200 as the sequence is set here, and you need to have this increment of 10. Okay. Then what you can see is to get all the sequences based on their name, max value, increment by last number. You can also add a synonym for a certain table name. Maybe it's too long. Like you have the tables between two relationships, many to many, you need to have the connection. Like table X has Y. So in this case, you can add a synonym. You can see all the synonyms, as well as you can drop the synonym MP1. Then you can also have an index based on department name. Okay, this department name. Okay, index IDX will exist based on the column name of the table department, such that you can search faster based on it. And here is the case when you also have a table, which is the sales department. You have a certain team ID, okay, which is a number of 3, as you can see, number 3, and it will be a primary key, as well as you set an index for it, such that you will have a sales primary key index based on the table sale department, so being the same table name, and you search according to the primary key. Okay, as well as we have here for the table sales department, we have in fact location. So if I add this one, let's see. So you have the primary key index, and you create the index in order to search based on it. Also based on the table and team ID as being the primary key. Okay. So I will also have the sales department. Okay, being here. Good. And you can even visualize which are these indices. Okay, so you have the indices name according to your table, which is sales department. Okay, and you have uniqueness, which in this case will not be unique. Then what you can do is to create a view. So a view is in fact you have a query, and what you can do is that you have the result of a query inside it, and then whenever you need it, you don't need to run the query again. You just have everything stored inside it. So let's see. Here you have to create or to replace an existing view, whether you run the query again and you've got other records, and you take from the table departments, you need to select the employee ID, last name from this table employee. So you take employee, last name, for which you add the alias as being employee, and department ID. And in this case, okay, it just exists as a view. So if I go here in SQL Workshop and I want to see my employee, okay, employee view does not exist as a view. It will have the results which you can further use. Okay. So if we have the commands, you see that it exists, okay, and you can have it for further computations. So it is just a result based on the tables which you want to join, or whether you have some aggregate functions, such that now you will have to solve several activities. Like here you need to have the department, and you have these department IDs for those who do not have the job ST Clark. So remember that this ST Clark, okay, job ID, and by going inside jobs and data, okay, it exists here. So it is in fact job ID. It is not a job title, such that you need to have all the departments, okay, but then you need to also have the minus. So don't forget that this is the way of having it in this case. So you take the same column names, okay, that you've got. Right here you have countries and country name based on location, right? Such that here you need the HR, okay? You need the HR department, needs a list of department IDs, okay, for those that do not contain, okay, the SD Clark, okay. So it would mean what? You will have the department underscore ID from, you take it from departments, and what you don't want to have. You have employees now and departments. Okay. So what would you write here? You need also the department ID. And this job, in fact, belongs now to an employee. So what do? You need to also get the department ID. So you will have the minus But now, for departments who do not have this department ID. So let's see. Here, departments, in order to find out the job ID, if you look inside departments, what do you have? You have department ID, department name, manager ID, location. So in fact, this department you need to look where. An employee has what? An employee has employee ID, first name, last name. You also have department ID and job ID. So you need to have it from the employee. So you select department ID from departments, okay, minus department ID from employees. And this is based on the result of multiple tables. So what will you have here? A department ID, okay, which is not allocated to any employee. This would be it. But we have the minus where we have job underscore ID, like single quote ST Clark. And now you have exactly those. So out of all the departments, you just neglect that which has the job ID ST Clark. This is how you take it one by one. Also, okay, you would like to see the details of all the employees who are sales representatives and they work in the sales department. Okay, so this would mean that you will have the intersection here in the middle based on what? You also have sales. So when having something like this, because it also, okay, let's see. So, or you have the link between them, but you need to check which is this value. So a sales department is in fact which one? That departments, okay, data, and we have sales. A sales department, okay, is this 80. Okay, so when going, and it's written as sales. Okay. We have these ones, and as we can see here, you have the department ID, and we need the one with 80. Okay, who are sales representatives. So what you will have is to also get the link between them as it was here. Which are the details of the person which you want to know. What would you add? Hello. So it can be last name, you can have first name. You take it from employees. Okay. But so you want them to have them as sales representatives. So it would also like this. You will have E last name, and you have E. You need to have the matching E last name and E first name. You take it from employees E, join departments D, knowing that the department of the employee is equal to the primary key of departments, D dot. And here you can also add something else. So now you would intersect those who work in a department. But now we want them to be working in a sales department. So you will have where D dot department ID is this AD. So now we will have the intersection of all the employees with those who work, okay, in the sales department. But we also have them as being sales representatives. So that one is from having what? We have also the job. So let's see the job which they would have. We were having the job title as SA rep. From what I recall, so we have employees, data, okay, then you have the job ID, and we want it as being a sales representative, so it's SA rep. So, and this is job underscore ID. So inside the SQL commands, I want this employee where job underscore ID like SA rep. Okay, and you intersect it based on department. So these are the ones who are also sales representatives and they also work in department 80. Okay. Then you can even update. So when you want to update all the salaries for those who earn less than 900, it's exactly the query that is placed here with update. You say which is your table and you set the salary according to the value which you want to reach. So it would be also 1000 and the salary to be less than 900. All right. Then what you would have to do is to see that a new row was added. So you can do the select or you can go here in object browser and to visualize it. Also, you can have the select star from employees where you have a certain ID. Then you would like to create a table department with this number and name, meaning that you have the department which I created here in the chat. This department, create table department, okay, based on ID as primary key. We have the constraint primary key and department name as being a varchar 2 of 25. Then you can even insert a row based on ID and department name according to the input values. Also, you would like to add a new column, so you would alter a table and insert the column which you need based on its type. So let's see where you have the, okay, so you have this alter table according to the table name, and you add a certain column based on the name of the column, the type of the column, and you visualize it. Okay. Also, you would like to have a view. So in this case, with the view, you would also have this constraint that you want them all to belong to the department 80. So you have this condition where department underscore ID equals 80 with check option constraint. And for the view, you have it here. You will have to create or replace a view. You have the word S, and then you have to write the whole query. Then if you want to see the result of your view, you will have to select star from it because you won't be able to see it inside the object browser as it is a case of this employee's view, which I did create. Okay. Also, you would like to reassign able to department 50, so it will not let you because it will belong to department 80. Okay, so you have here, you go to employees. Okay, and data. You have the constraint and it will not let you. So this able. Okay, see, as it belongs to department 80, you have the constraint. And when you will want to update and to set the department ID for able to be 50, it will not let you due to this constraint which you added for exercise 7. Let me stop the recording and then I will ask you whether you do have